9.4, number 10, we're asked to determine convergence or divergence of the series. Identify the test or tests you use. Okay, so for this one, it's usually a good idea to choose the nth term test. That's a way to prove that the series diverges. If the limit as n goes to infinity is anything other than 0, it's going to diverge. So if we find the limit of this as n goes to infinity, let's see if we do get 0. So anytime you have, well, if we put infinity, we're going to get 1 plus 1 to the infinity. 1 to the infinity is not 1. 1 to the infinity might be 1, but it's indeterminate. So since it's in indeterminate form, let's take it's a variable to a variable. Anytime you see that, you want to do a natural log. So let's do the natural log of 1 plus 1 over n to the n. And then this n can go up front, so it's n natural log of that stuff. And we have to write it as a rational expression, in other words, as a fraction. So we can move the n to the bottom, so we have n, the natural log of 1 plus 1 over n over 1 over n. N is going to infinity, so we take the natural log of 1, which is 0, over 1 over infinity, which is 0. So it is an indeterminate. Okay, so derivative of top, L'Hopital's. So the derivative of the top is 1 over 1 plus 1 over n times the derivative of the inside, which is negative 1 over n squared, over derivative of 1 over n is negative 1 over n squared. Okay, so those divide out. So then I have 1 over 1 plus 1 over n. And as n goes to infinity, I end up getting 1 over 1 plus 0, so we get 1. And remember, we did do e to the power, or natural log, so we have to do e to the power, so we get e to the first, or e. Alright, so it's a good thing that we tried the nth term test, because we did get a number besides 0. So since it's not 0, the series diverges.